Hello, algebra students. This is Mrs. Palmer, and we're going to talk about factoring again, but now this time specifically factoring by grouping. This type of factoring is sort of particular. We have already talked about factoring differences of two squares and GCF factoring, and the reason we would want to factor by grouping would be that some of the other choices we have wouldn't be available to us. For example, if you look at the polynomial right in front of you, you'll see that there is no GCF that could be pulled out of those four terms. They don't share any single thing. So the way grouping works is it actually uses the idea of a GCF in a slightly different way. So to start this process, you would want to, I always say, sort of separate your polynomial into two equal parts, two terms in the front and two terms in the back. And if you just look at the two terms in the front, you'll see that you can take out a 2a squared as a GCF. And if I take out a 2a squared, I'd be left with a 2a plus 1. Sorry about that little line there. And then if we just completely forget about that side and come over here to the end, you'll see that you have 10a plus 5, and there's a GCF there of 5. And if you take that out, you'll get 2a plus 1. And here's how grouping works. Because when we took out the GCF of each of those pieces, because the term in the parentheses matches exactly, and it does match exactly, we can pull that out front. Pull that out front. So now let's take 2a plus 1 out as though we were factoring out a GCF. And what would we be left with if we took away the 2a plus 1? We'd be left with this 2a squared plus 5. And as usual, the way to check factoring is to multiply it back out. In this case, we would FOIL this back out. And as we do our first terms, 4a cubed plus 10a plus 2a squared plus 5, you'll see that while I did write these slightly out of order, they are exactly the same. So this would be our result. As always with these presentations, you can pause anytime you need so that you can copy down what you might like. All right, so let's do just a couple more examples here. Looking at the first one, looking at the first two terms, I can take out an x squared. I'd be left with an x plus 1. Oops, there that is again. Move over, plus 2. Take out another x plus 1. So now, because the parentheses are exactly the same, I can take those out, both of those out, as though I were factoring out a GCF and have an x plus 1. And what would I be left with? An x squared plus 2. As always, again, encourage you to multiply it back out to make sure that you end up with the polynomial that you started with. So let's do this one. Can take out a 2b from the first two terms, and I'd be left with a 2a plus a b. And I can take out a 3, and I would be left with a 2a plus b. Because these match, and I hope most of your astute students who are watching this are thinking, well, what happens if it doesn't match up? Well, we will get to that. Okay, so 2a plus b and 2a plus b. And I can pull that out. And I'm left with 2b plus 3 as my answer. There it is. Now that we've got two examples on this page, I want you guys to notice a few things. There was no GCF that could come out of all four terms at once. That's why we had to split it up. But also one key clue that factoring by grouping might be a possibility is you see four terms. You see four terms, not a trinomial that we've worked with or a binomial, but we see four specifically. So one idea that can be a little tough is this one. When you go to group and you take an x squared out here, well, that's no problem. We see how that works. But then we go to the last two terms, and we see that the only thing that they would have in common would be a 1. And that's okay, because if you put a plus 1 right there, you will get x plus 1 in the parentheses, which will match the x plus 1 we got up here. Pull that out front, and it will work. So the troubleshooting idea that I am highlighting here is this one, that sometimes using a 1 can make the problem work for you in terms of factoring. So a little troubleshooting here. Let's just see what happens if we go at it directly. Can take a 3a out, and I'll have a 2a squared plus 3. And then I can take a 5 out, and I'll get a 3 plus 2a squared. Well, guys, these things are the same even if they're in a different order, because we know the commutative property says that addition works in both directions, so it doesn't matter whether we say 2a squared plus 3 or 3 plus 2a squared. They are exactly the same quantity, so we will make a decision. I'm going to call it 2a squared plus 3, and group the 3a and the plus 5. All right. So negative signs definitely make this process a little more challenging, and we'll see that right here. If you take a b squared out in the front, that's no problem. But then you have this subtraction sign, and you're thinking maybe a 1, right? And that's a great idea. But what would be left here is a b minus 1. Now that's a good thing for us because we want it to be a b minus 1. We want it to match. But I hope that you see that this becomes a b minus 1 because there's a negative sign in front. So it's because if you were to redistribute that negative 1, it would become b plus 1. So that's why it works out. So these guys match, group them, put them in front. And then we'll be left with b squared minus 1. Just a little review here. I hope that we recognize that b squared minus 1 is a difference of two squares. And we can continue factoring it. And I don't know why I just rewrote it, but here we go. That becomes b minus 1, b plus 1. So we actually end up with this original b minus 1, another b minus 1, and b plus 1, which we could write. This is fine, but we also could write that. And let me shift colors here just so you can clearly see it now that I've made quite a mess of the screen. We could write it as b minus 1 squared times b plus 1 as a final answer, which would be the neatest, most concise way of writing that. Now let's talk about when it doesn't work. And if we were to go here and take out a 3, and we get an a squared minus 2b squared, and then we were to go here and take out a 2 and get a minus 2b. All right. Okay, so let me just first check that I did everything correctly. Yes, it looks like I can only take out a 3. All right, it looks like I can only take out a 2. But you can see here that these guys do not match. They look kind of alike, but not alike enough to make this match for us. And one common idea is sometimes maybe we can move some of these terms around, and maybe it would work better for us. But you can see if I were to take the original problem and move a few things around, that's not going to help me out here, because when I split it and factor, I'm going to get only A's and then only B's. So that's not going to work either. So we're sort of stuck here, guys. This is about as good as it's going to get for us. And this, we would say, is prime. We just can't factor that any more than it already is. So it doesn't work. That doesn't work. That's not going to work. Okay, so just in wrapping up, I just wanted to say that this is a very particular form of factoring, and it's very particular based on the fact that you have these 4 terms to start with, so that's always a clue. When do I know I want to factor by grouping? Well, do you see 4 terms? Because then it's a likely candidate. Okay, thanks guys, and happy learning.